Okay, so this is the work you probably, hopefully, did today in class while I was absent. So I'm going to put it, review it. So here we go. Larry had 3/5 of a pizza left. He wants to share with 3 of his friends. A fraction of pizza will each person get, include Larry too. Use a model only to find your answer. So here, let's draw 3/5 of a pizza. Got 1, 2, 3, 4, 5, and I'm going to shade this 3/5. And we want to share this with 4 people. It's 3 friends and Larry too. So it's 4 people. So I'm going to take the first one and cut it into 1, 2, 3, 4. And I'm going to call this Larry, friend A, friend B, friend C. Cut the next one in 4 pieces as well. The other one in 4 pieces as well. And even the empty ones, I'm also going to cut them. Okay. So the ones we have, this goes to Larry, this goes to person A, person B, person C, Larry, person A, person B, person C. So if the sentence should have been this, divided by 4, right? 3/5 divided by 4. So what did Larry get? Well, Larry got 1, 2, 3 slices out of a total of how many? 1, 2, 3, 4. 1, 2, 3, 4, 5 out of 20. So each friend got 3 out of 20. Friend A got 3 out of 20. Friend B got 3 out of 20. And friend C got 3 out of 20 as well. Okay, so just by modeling, you could tell that the answer was 3/20. The other one, Mary had 4 chocolate cakes. So let's draw. Oh, actually, you know what? Let's write the sentence of 4 chocolate cakes. We're going to divide that among, or cut them up in 3/4. How many 3/4 pieces can we make out of 4 chocolate cakes? So let's draw the 4. 2, second chocolate cake, third chocolate cake, fourth chocolate cake, right? And every friend that she sees will get 3/4. So we want to make sure we cut this in fourths. 4, 4, 4, half, half and half, half, half and half. So she has, okay, and you shouldn't, I see sometimes you guys highlight 3/4. No, highlight the whole thing because that's what you have. You have a full cake, another full cake, another full cake, and another full cake. They're brand new cakes, just come out of the oven. And every time you meet a friend, you're going to give him 3/4. The first friend gets these 3/4. The second friend gets this second 3/4. The third friend gets another 3/4 of a cake. Fourth friend gets another 3/4. And then we got going here, that's also 3/4, right? So I can give it to 1, 2, 3, 4, 5 friends will surely get 3/4. But the last person here, you can't give 3/4 to that friend of yours, but you can give him 1 piece out of the what? The 3 that you were giving. Remember, every friend got 3 pieces, right? 3 pieces, 3 pieces. And so, but the friend number 6, unfortunately, didn't get a whole 3/4, the whole 3 pieces. He got 1 piece out of the 3 you were trying to give. So here is your answer to that question. The following 4 questions, use a model and the denominator method. Okay, so let's use the denominator method where we cross it out. So the LCM here is 10. And we're going to change the denominator, we're going to change the tops, times 2, times 2, 6, times 5, times 5, you get 5 over here. You cross it out, right? You get 6 divided by 5, or we'll write it down as a fraction. And you get 5 goes to 6, 1, 1/5. So I'm going to draw the second part, 6/10 and 5/10. So 6/10, I'm going to do 6/10 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And divide that by 5/10, right? This is a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is definitely a grouping problem. 6/10, 3, 4, 5, 6. 5/10 is 1, 2, 3, 4, 5, right? So how many 5/10 fit into 6/10? So we got 1, 2, 3, 4. I need to draw one more. Sorry, 5/10. That's 5/10. So how many times can this group of 5 fit in the group of 6? Well, it can fit. Let's see, 1, 2, 3, 4, 5. You can make. Oops. Let's try again. 1, 2, 3, 4, 5. So you can make one group of 5, right? Right? One group of 5. And you have one left over. And if you try to make another group of 5, you can't. You can make one group out of the 5 you were trying. So that's why your answer is 1 and 1/5. Okay? These 5 will fit here one time. If you try to fit it again, only 1 out of the next 5 are going to fit in. And that's how your answer is 1/5. LCM, here's 12 times 3 times 3 on top is 3 times 4 times 4 on top is 8. Cross this out. We're going to get 3 out of 8. That's the final answer. So again, let's draw this out. In this case, we're drawing 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we're going to draw 8 at 12 again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we're going to shade 3 because that's what we have. And 8 goes up to here. That's 8 12s. How many times can these 8 fit into 3? How many groups of 8 can you make out of 3? Well, you can only make a group of 3. You made a group of 3 out of what you were trying to do. You were trying to make a group of 8. You couldn't, but you made 3 out of 8. Another way of thinking about this is how many times these 8 fit into these 3. Not all of them fit, but 3 of them fit out of the 8 you were trying. So, again, both methods reflect each other. This one, the denominator is already the same, so that's nice for us. We'll cut them into fourth. 1, 2, 3, 4. I'm going to need actually a few of these. 1, 2, 3, 4. Remember, the first fraction is what we have. Right? 1, 2, 3, 4. So let's shade in 9/4. 9/4 is 4/4. 5/4, 6/4, 7/4, 8/4, 9/4. This is what 9/4 is. At the bottom, we're going to shade 3/4. How many times can this 3/4? I move just that color. How many times can those 3/4 fit in the 9/4, right? Oh, these 3 can fit inside once, can fit inside twice, can fit inside 3 times. Oh, look at that. So according to my model, the answer is 3. Oh, if we do it the other way, we cross this, right? You get 9 over 3, and 9 over 3 is indeed 3. So both ways work out. 1 2/3, let's change that to an improper. 3 times 1 is 3, plus 2 is 5, so you get 5/3 divided by 2/3. Let's draw that. 1, 2, 3, 4, 5. Nope, sorry, that's wrong. We got to cut it into thirds. 1, 2, 3. Cut another 1 2/3, right? At the bottom, 2/3. 1, 2. So let's show what 5/3 is. 5/3 is 1/3, 2/3, 3/3, 4/3, 5/3 right here. And then the bottom is 2/3. Okay, so this is a grouping question, right? So how many times can these 2 fit in the group above? Well, these 2 can fit obviously 1 time, 2 times, and so for sure 2 times. And if I try to put these 2 in here, both of them will not fit, but 1 out of the 2 will fit. If we do it crossing out the same denominators, we get 5 divided by 2. Let's write that as a fraction. Is 5 over 2 the same thing as 2.5? 2 goes to 5 2 times. 1 left over 2. They both have the same answer. So this one we're not modeling anymore, so makes life. So the LCM is 24. 8 times 3, so it's 21 on top. 8 times 4, so 5 times 4, which makes it 20. cross, and then you get 21 over 20. 20 goes 21 one time, 1 over 20. 7 and 12, the LCM is, I'll say 84. Is there anything? No, it doesn't look like 84. 84. 7 times what's 84? It's times 12, and then top times 12. 3 times 12 is 36. 12 times 7 is 84, so on top is going to be 11 times 7, which is 77. You get 36 over 37. I don't think we can simplify that. Let's change this mix to improper. 4 times 5 is 20, plus 1 is 21 over 5, divided by 7 times 2 is 14, plus 3 is 17 over 7. Now we can find the LCM, which is 35. Times 7, right? Times 7, so I multiply the top by 7, we get 147. Times 5 at the bottom, so times 5 on top, which gives 5, 35, 85. Cross, you get 147 over 85. You can definitely change that to a mixed number. 85 goes to 147 one time, and you're going to have 214 minus 8, 62 over 85. Okay. Again, let's change this. 8 times 2 is 16, plus 5 is 21 over 8. Divided by 5 times 1 is 5, plus 3 is 8 over 5. LCM is 40. This is times 5, it's going to give you 105. This is times 8, which is going to give you 64. You get 105 over 64. 64 goes into 105 one time, and you're going to have 10 minus 6 is 41 over 64. 41 left over 64. Okay. Clear. Create a group in your sharing problem. Tell me why it's a group in your sharing problem. Well, so this one. Okay, so let's try something simple. 2 divided by a half. Keep it simple. This is a grouping problem because you can say 2. If you have 2 of something, can you divide it by half of a person? Can you share with half of a person? No, so it's a grouping problem. How many halves exist in 2? Okay, so I'm going to have to explain all that. Okay, so how many halves exist? So if it's easier for you to say that, then it's a grouping problem. It depends on how you interpret it. Let's go backwards. Can you have half of something and divide it among 2 people? Yeah, that makes sense, right? You can have something like this, the chocolate bar, and you have half of something, half of the chocolate bar, and 2 of your friends, you're going to split it up. And split up with 2 of your friends. Friend A gets this one, friend B gets this one. That's something that's possible to do, right? So this is definitely easier to interpret as a sharing problem. Whereas this, you have 2 chocolate cakes. Let's just stick chocolate bars. 2 brand new chocolate bars, which you'll probably get a lot of tomorrow, being Halloween. 2 chocolate bars, can you share it among half a person? No, you can't, right? So, but it's easier for you to imagine how many halves exist in 2. How many, if you were to cut these chocolate slices into halves, how many halves do you have? You got 1 half, another piece that's a half, another piece that's a half, and another piece that's a half, right? So if you were to get a chocolate bar and cut into halves, you would have how many? 4 pieces. Now over here, you had half, right? And then you cut that half into 2 smaller parts. One you gave to friend A, the other you gave to friend B. How much did each friend get? Well, don't remember to cut this empty space as well. So friend A got 1/4 of a chocolate bar, just like friend B also got 1/4 of a chocolate bar. Okay, so that's what you should have done today. Hopefully that will work also as a review. Okay, for tomorrow's quiz if you're in 606, and Wednesday if you're in 604.